Make sure you've given this a go before you watch the video. There is an answer there. Anyway, so we have an exponential function and a tangent to it, which is clearly a straight line, and we want to find a bound area. A bounded area? Anyway, an area. Without some sort of manual diagram, your ability to do some sketching without a calculator, this is going to be very hard. Y equals e to the x plus k. So it's exponential with an asymptote. Usually without the k, we would have a y-axis intercept of 1. So if I can find my point k, and I'm going to go up 1, I'm going to come roaring in and then just go up like that. Somewhere along the lines, I'm going to have a point where there's a slope, y dash equals to e, and there's my tangent, is going to come rocking down there. There's my point of intersection, and there's my bounded area. Yeah, okay. And this tangent function is y equals, it's got a slope of e, but I don't know its y-axis intercept. Okay, first thing, we've got to find where the slope is equal to e. So let's come back up here. Okay, so clearly we are going to differentiate, and then the k goes. We want to find the x value when y dash, where the slope is equal to e. And clearly you can see x will be 1. So straight away, we know that that point of intersection happens where x equals 1, and we've got the bounded area with the y-axis. So we've worked out our integration bounds, which is great. Now we need to find this as a point so we can find our tangent function. So we're going back to our exponential and going, when x equals 1, y will equal e to the 1 plus k. So there's a point on the exponential, that's 1, e plus k, and that's the point where the tangent touches, so it's a point of intersection. This point is on the tangent. So that tangent was y equals e times x plus c. We're going to find c by substituting in that point of inflection, point of intersection. So when x is 1, y is e plus k. Rearrange that and you'll get c equals to k. So our two functions are the exponential and the tangent, e times x plus k. And we want to find the area between them. Clearly the exponential is on top, so we're going to do area is the integral from 0 to 1. The function on top goes first, and the function on the bottom, we're going to subtract that away. Dx. Clearly that k minus that k cancel each other out, so we get this rather simple integral after all of that effort. Integral of e to the x. Integral of e to the x is, e times x is e to the x squared on 2 from 0 to 1. We're going to put the 1 in and then the 0 in. So the 1 in first, e to the 1 is e, 1 squared is 1. Then put the 0 in. So we're going to have e minus a half is e on 2 minus our 1 in the second bracket. I'd be happy with that in the test, but you can see that that's the same as the answer down the bottom. I'm happy with either if you get that. Ended up being quite an easy integral, but it highlights your need to be able to play with functions without a calculator, know what they look like, be able to sketch a graph, understand your bounds. Really like that question.